Okay, let's look at some more large-scale geothermal applications, commercial geothermal applications. Quick overview.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that is seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But
So this is where we talk about our plate boundaries being most accessible areas for geothermal harvest. But with enhanced geothermal systems, or EGS, enhanced geothermal systems, we drill and can capture all the energy we need to run turbines pretty much anywhere in North America.
as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator.
This is the binary systems we can use a lower temperature, harvest a lower temperature to produce large-scale energy, electrical energy.
The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy.
Here we are, re-injection. So the water that is below the aquifers in general. So we just got to make sure that the drilling techniques are compatible with the aquifers, that there's no seepage and that there's no leakage from the substrata into the aquifers, which can be an issue if there's not good grouting on the pipe or not good sealage on the drilling operations.
Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
Sweet. That's what we're looking for. So let's take a look at some, so we say, footage on the actual geysers, basins, the area that he was talking about north of San Francisco. And remember, that's in correlation with the tectonic interface, the San Andreas Fault, transformal fault, and the subductive aspect of the suboceanic plate diving under the North American continental plate. So let's take a look at it here real quick. Obviously this resource is very close to the surface. So obviously the problem is now with these types of geothermal features is that they're protected, and we can't just go, bopping in there and plop a pipe in and start drying up this resource, because it's it's a, shall we say, a state treasure or a federal treasure. So what we've got to do is let's take a look at this geyser region from our Google Earth here. Let's take a look at it. So here's where we want to take a look. You can remember that you can click on your real-time earthquakes browser here, real-time earthquakes, tectonic plate boundaries. If you have this turned on, you can see how that turns, this tectonic plate boundaries turns on the continental, different types of plates: transformal, convergent, rift boundaries, spreading rift. So you take a look at this coming along here, the oceanic convergent coming on down, then we got the oceanic transformal fault. So then we have the subduction zone in blue, as you see right along here, right along the California coast, this large subduction zone, 39 millimeters per year, which is substantial. This whole suboceanic plate is diving under the continent here, and that's that indicated by this blue subduction zone. And then there's the oceanic convergent, and then the green oceanic transformal fault. So this is where you get the shearing. And let's take a look at the San Andreas along here. San Andreas fault coming down in through here. The San Francisco area, and then that geyser basin that they were talking about. So where's Geyserville? Here it is, right here. Come on down into Geyserville. And you can see that the general formation here of previous subduction, as this oceanic plate dives under the continental plate, it tends to bulldoze up these mountain ranges. And you can see here the Inner Valley, and then here's the Sierra Nevada mountains. And if you take a big look at it, You can see how that resembles the coastline of the United States. The Sierra Nevada mountains, and then we come on here to the Rocky Mountains also. Remember, the mountains are formed by converging plates pushing against each other and forming the mountain ranges. So if you kind of use Tahoe here, Lake Tahoe as a where they have some of these geothermal plants. So you put in geothermal energy companies in the search, and Calpine Corporation comes up here. Here's Calpine right here. Let's take a look at it. Let's see if we can see the plant. See that it's spread out all over the place. Very little impact. That's a helicopter pad right there. Calpine Corporation. You can see the production wells and the reinjection wells. Some of the piping right here. So you can see there's no huge impact. There's no great big craters or huge cooling towers. You can see some of the actual generating facility right here. See the cooling towers here. And then you can kind of take a look and see where some of the pipes take off. So this would be a production well right here. And these arches are to get over roadways or over obstacles. They also tend to start to separate steam. But now you can see this pipe coming off here, going way on out here to another one of the production wells, or this, let's see, this is a reinjection well here. Let's get out of ways. There we go. So some of the brine solutions that they have in their storage facility here. So here we go. You can see that the series of production wells here. So here comes here's where they've drilled into the resource, and then now this also has to do with the geology. So we look and see, okay, it'd be nice to have what's called a geological pan at the bottom of your fractured out reservoir, so that the hot tends to rise. So that the hot rises to the high end of the reservoir, and then you re-inject like we saw before. Re-inject right at the site when you're done with it. So here's your re-injection, and notice the difference in color. So you got your production and then your re-injection. The darker pipe. So that way you don't have a depletion of your aquifer. So there's a look at Calpine Corporation. Let's see what they have to show us. So what might this Calpines look like? Let's take a look at some of this stuff. antiquated or obsolete Calpines facility, but pretty much bomb-proof. It's going to be fireproof. Why not live in it? You can see some of the other facilities. See them all dotted all over the place out here. All these different piping and different, but some of these are still active. We're going to look at some of the active features also. But kind of interesting. For sale. I wonder what the price is. Check with Pacific Union Christie's, huh? There we go. Price $3,700,000. Owner may carry paper. Structure 60,000 square feet. 57-acre parcel. Only $3,700,000. I wonder what kind of hazardous waste issues you have. It's built in a geothermal plant in the state of California. It's probably like a bomb shelter, that thing. It looks like it's all concrete. A few holes in the wall, but I don't know. Looks pretty decent. Anybody want to buy it? So let's take a look at the plant itself here. Or a portion of it, small portion of it, one of the cooling towers. It's Forest Fire City up in there. See how they have a pretty good buffer zone around their facilities. All made out of concrete anyway. These are the cooling towers. Calpines Calistoga Geothermal Power Plant steam stacks at the geysers in California. Your large-scale geothermal. A lot of this had been let go because the pipage had calcified and the things plugged up, but they rehabilitated it. That's what we'll see here with the reopening in 2012. So check it out. Here's the Calpine Geysers Visitor Center grand reopening back in 2012.
Hi, I'm Deborah Summerfield. I'm with the Lake County Administrative Office and involved in the county's economic development and marketing program. I'm here at Calpine's Geothermal Visitor Center and excited to see the new exhibit that they have here today. Calpine.
So if you're into turbines, you can see it looks like 1, 2, 3, 4 stage, maybe a 5-stage turbine there. Let's see, I think these are the sealage rings right here. Initial induction fins, but at least a 5-stage turbine. And you times 2, right? Pretty cool.
And has been a great partner with the county in terms of a major employer in the county, and in addition, having the Calpine Visitor Center here in Southern Lake County is a wonderful opportunity for visitors to learn about geothermal energy in just a great exhibit space, hands-on demonstrations, informative presentations, and it's just going to be a truly wonderful asset here to folks visiting Southern Lake County.
My name is Danielle Mathis Paris. I'm the manager of Government Community Affairs for the Geysers, And here today we have remodeled our exhibit room, and the goal is for some of the people that collaborate on the project to be able to interact with our visitors and explain what story they wanted to tell. Geothermal's complex, there's a lot of different components, and so everyone who worked on it can stand and talk about what they were trying to convey in a very small exhibit. Geyser spans 35 square miles, and there's a lot to it.
Slow down, it's getting too bright.
Okay, the main thing I want to point out about the geysers is that the geysers is in rather ordinary rock found throughout the entire coast ranges of California. And the geysers is in this rock called gray rock, this gray area here. And it's very abundant throughout this region. But the reason that the geysers is here is because a body of granite came in below the geysers and it fractured this gray rock and it since prepared it for a geothermal reservoir.
I'm Mike Rogers, Senior Vice President for Calpine's Geothermal Region, and we're here at the Calpine Cartwright Geothermal Visitor Center located in Middletown, Geothermal Division, and what we're able to do is upgrade all our exhibits. They're all state-of-the-art with touch screens and a lot of interactive exhibits, so it's really turned out to be a great facility. The facility's open Wednesday through Saturday, 11 to 5. So come on down to Middletown, you'll find it to be a really great facility. Lake County has been great for the geothermal industry. Obviously, there's a phenomenal resource here, the geysers that straddles Lake County and Sonoma County line. This is the largest geothermal facility in the world. We've been operating up here for over 50 years, and we found that the Lake County is great to work with. We have a great workforce, 75% of which reside in Lake County. We find that the local vendors, the communities, and the government officials are really good to work with and are really welcoming of our business. So we feel we have a really great partnership with Lake County, and especially in the South County part where we work really well with the folks here. We've got a lot of suppliers from folks that provide us tires all the way down to people that provide us with food for some of our meetings and events. So Red Lake County's been really good to Calpine, and I think it's been a very symbiotic relationship.
So there you have it, the Calpine's Calistoga Geyser Visitor Center. But let's take a look at induced seismicity here. With 35 square miles under production there, that's a pretty big facility. I think there's a bigger one in the Philippines, though. The guy, he might not be up to speed on calling that the biggest facility in the world.
Welcome to one of Cal Energy's geothermal power plants. Unlike other power plants that rely on coal or other fossil fuels to create electricity for homes and businesses, geothermal power plants use superheated fluids from the Earth's geothermal resources to generate electricity. The natural heat of the Earth creates geothermal resources. This heat comes from molten rock called magma, located at the Earth's core, deep below the geothermal resource. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoirs. The magma heats the water until it becomes a superheated fluid. To reach the superheated fluid, wells are drilled 5,000 to 10,000 feet below the surface of the Earth. These wells, called production wells, bring the superheated fluid to the Earth's surface, where it can be used to generate electricity for homes and businesses.
Key term, production wells, producing the geothermal heat, the steam that we need to turn the turbines, produce the power.
This geothermal power plant uses crystallizer reactor clarifier technology, a process that turns the geothermal superheated fluid into steam while removing solids from it. The steam is used to drive a turbine and generate electricity. All remaining geothermal fluids are injected back into the reservoir for reuse.
So here's where we diminish that issue that they had with depletion of the reservoir or the fluids, the reinjection into the reservoir for reuse.
Under its own pressure, superheated fluid from the geothermal resource flows naturally to the surface through production wells. As the liquid flows toward the surface, the pressure decreases, causing a small portion of the fluid still within the well to separate or flash into steam.
Thus, the flash steam systems that we talked about, these are not always available because of the temperatures required. But in the Calpines area, this is a very, very good resource. 35 square miles that are applicable because of the subterranean geology there. That magma or the granitic monolith that came up and then actually fractured the overlying rock, so it we didn't have to go down there and fracture it ourselves or fract it. It was done naturally.
At the surface, the superheated fluid and steam mixture flows through surface pipelines and into a wellhead separator. Inside the separator, the pressure of the superheated fluid is reduced. This causes a large amount of the superheated fluid to rapidly vaporize and flash into high-pressure steam. The geothermal fluid that is not flashed into steam in the wellhead separator flows to a second vessel called a standard pressure crystallizer, where an additional amount of standard pressure steam is produced. The flash process continues in the low pressure crystallizer. The remaining fluid is again flashed, this time at a lower pressure to produce low pressure steam. All of the low pressure, standard pressure, and high pressure steam is delivered to a turbine. The fluid that is not flashed into steam flows into the reactor clarifier system and is then returned to the geothermal reservoir through injection wells. Turbines are the primary piece of equipment used to transform geothermal energy into mechanical energy. Pressurized steam created from the geothermal superheated fluid flows through pipelines to large steam turbines. The force and energy in the steam is used to spin the turbine blades. The turbines turn a shaft directly connected to an electrical generator. An electrical charge is created when magnets rotate within the generator. Large copper bars carry the electrical charge to a step-up transformer outside the plant. Within the transformer, the voltage is increased before the power is sent to the power lines that carry it to homes and businesses. Geothermal energy is a sustainable resource because with proper management, a geothermal resource can remain a renewable source of energy. Water trapped deep within the earth will naturally replace the superheated fluid that is drawn from the geothermal resource through surface wells. However, it is possible to deplete the geothermal resource by removing fluid faster than it can be naturally replaced. To help prevent this, the steam used in the geothermal power plant passes through a condenser that turns it back into fluid. At this stage, it's possible to recover minerals from the geothermal fluid before it's injected back into the earth. This condensed fluid, along with the fluid that did not flash to steam, is injected back into the underground reservoir. Magma naturally reheats the fluid so it can be used again.
Very cool. Totally sustainable.
Hydrogen sulfide are extracted and routed to scrubbers and cleaned. The turbines are designed for steam inlet temperature and pressure of 355 degrees Fahrenheit and 100 pounds per square inch. About 1 million pounds of steam per hour are required to operate a 55 megawatt net generating unit. Jetting against the turbine blades, the steam spins the turbine that drives the generator to produce electricity. Spent steam passes through the condenser, where non-condensable gases like hydrogen sulfide are extracted and routed to scrubbers and cleaned. The condenser also cools the spent steam, so that it forms liquid water or condensate. The condensate is then pumped into the cooling tower. About 75% is evaporated as part of the cooling process. The remaining 25% is injected back into the steam reservoir, where it will eventually be
Geothermal energy. The mystery about the shape and size of the earth is nothing compared to the mystery of what lies inside it. One such